To win the spaceport competition, there's a target altitude of launching a rocket to 10,000 feet with an 8-pound payload. That's not an easy task. The Rocketry program at San José State starts at the basics, and we teach the students how to build simple rockets and evolve all the way up to very complex, high-power rockets that allows them to compete at spaceport on an international level.
So San José State has a long tradition of hands-on learning, especially in aeronautics and aerospace engineering. We've had competitive rocketry teams for some time.
In many engineering programs around the world, students only learn how to design things on paper. What we do differently here is students not only design things, airplanes, spacecraft, rockets, but they also have an opportunity to build them, test them in the lab, and actually go out there and launch them. So that's what makes our students more valuable to industry, because they're hands-on, they're not theoreticians.
It's not cheap, and it presents a lot of safety challenges, which it's really important for our students to be able to understand how to work with these materials safely.
The challenges of building a rocket of this nature involve many disciplines. We have to have students that are involved with all aspects of it, with telemetry, with the avionics, with the computers that control parachutes, with the parachute deployments, with the motor selections, with the computational fluid dynamics, with the fin designs, and also with material selections. So every student is learning this whole spectrum of how to build a rocket, of all the disciplines combined into one, which makes them very good systems engineers.
So to do well in this competition, we need good computational tools because the rocket has to perform very accurately. It needs to reach as close to 10,000 feet as possible, not below and not over. So it's a very complex calculation that takes into account the aerodynamics, the stability of the rocket, the propulsion, depending on the engine that we use. And that's where Cadence software comes in to help the students be as precise in their prediction of rocket performance as possible.
When students are using Cadence CFD products, they're able to do detailed designs, and this enables them to swap out materials, for example, without having to buy and build a design with that material. It enables them to understand the safety of their design in a much more detailed fashion. And so it gets us closer to the goal with a lot less expense and a lot less risk to our students.
The CFD program allows us to design a rocket nose cone that's going to produce a shock wave that gives us the proper flow, whether it's laminar or turbulent flow around the rocket, and it's going to allow us to know what that flow is when it goes down to the fins so that we can get proper stability throughout the whole flight.
The Cadence CFD software allows us to make a much more accurate prediction of the dynamics and propulsion of the rocket, so we can predict how high the rocket will reach as accurately as possible.
Yeah, San José State has had a great relationship with Cadence over the years. We really appreciate this partnership. It's part of the reason why our students are so valued in Silicon Valley. I think when they have exposure to state-of-the-art tools used in industry, it makes it much easier for them to transition either into the workforce or into graduate school. We're thankful for Cadence support.